All right, this will be the start of Unit 2, which is all about angle relationships for integrated 2. If you haven't written what I have on the side with these corresponding angles and alternate interior angles, I would definitely do that on your top of your notes because that's going to be helpful, like where it says helpful notes and formulas. That will help us to answer a lot of these questions. So corresponding angles, basically this is like a copy paste. If I was going to copy this angle and then just move it up and paste it. So these are congruent. So if I know that this one is, so if I know that this angle is 25 degrees, then this angle is also 25 degrees. Alternate interior angles, so kind of like a flip and inside. So inside, flip. These are also congruent. So if I know that this angle right here is 37 degrees, then this angle right here is also 37 degrees. Vertical angles, they make like V's next to each other, V's that are butted up against each other. They're also congruent. So if this one was 17 degrees, this guy would also be 17 degrees. Alternate exterior angles are also congruent. So again, if this was 55 degrees, this guy would be 55 degrees. Complementary angles add up to 90. Supplementary angles add to 180. And vertical angles we already covered up there. But either, anytime you're setting up these types of problems, either they're going to be the same value, so like 37 and 37 degrees, or they're going to add up to 180. So an example of that would be if I had that same little parallel lines cut by a transversal. If I had this angle was 35 degrees, these are supplementary angles or linear pairs because they add up to 180. So if I wanted to find this angle right here, let me get a different color. Yeah, back. So if I wanted to find this angle that's in green, if it will write in green, that's great. I would do 180 minus 35 because both of them add up to 180 degrees. Which equals 145. So these are also, if they are, let's see, like this angle and this angle would also add up to 180 degrees. So you can tell a lot by looking at the picture. Obviously, if I look at this picture, this angle right here is much bigger than this green angle down here. So I know that they're not congruent to each other, they're not equal to each other, but they're gonna add up to 180 degrees. So like if this one was 70, then that would be a bad. If this one was 110 degrees, then this one would be 70 degrees. 110 plus 70 is equal to 180. So this first problem is just asking us to identify the relationship, and we may need to use more terms than once. So we're looking at this word bank right here, which is also our pictures right here. So angle 4 and I'm going to use a whole bunch of different colors, angle 4 and angle 8. Looking over here, it looks like those are corresponding angles because I can just copy 4 and move it up to number 8, so corresponding. One and 5. Let me get a different color. One and 5. So here's angle 1 in blue and angle 5. Also corresponding. So if I copied and pasted and just moved this line up, it would be the exact same angle. Another color. 6 and 7. So 6 is here, 7 is here. Those are V's next to each other. They look like this right here, vertical angles. Three and 6. Running out of colors here. I need a different color. Okay, well, my new colors are not working, so we're gonna be trying this again. Bear with me. Why do I have two mouses? Go with purple here. I'm gonna keep with the numbered ones and then we'll go into the CED, BED. So I'm gonna save G and H for last. So 3 and 6. 3 is right here. 6 is right here. Those are alternate interior angles. Three and 5. Those are same side interior, so they're on the same side and they're inside. I ran out of colors, so you'll have to bear with me with the colors. And then last 2 and 4. 2 and 4 are a supplementary angles or a linear pair. All right, CED, so C to E to D. So this angle right here, CED, and BED. This angle right here. Those definitely are not equal to each other. They are on a straight line, so we're going to call that also a linear pair. I'll use a different color for this one. BED, so say the same angle that we just had, BED. Ooh, BED is, and AEC, AEC are vertical angles. So now we're still using those same properties as what we just had. We just now need to find what the other angles are equal to, given that one angle is 120 degrees. So this angle is 120 degrees. Let me fix my degrees sign. 120 degrees. Now I need to find angle 2 and the angle relationship that we have. So angle 2 is definitely not congruent. This guy is much bigger. 120 degrees is much bigger than this 2 to 2 is. So I know they add up to 180. So I'm trying to find what 120 plus what number is equal to 180. I can subtract 120 to the 180 and get 60 as my other degree. What I will tell you is these types of problems, the majority of them are either going to be 120 or 60. So those are kind of your two options for answers on problems like this. So once you find that other angle that's like the corresponding or the linear pair to the angle that's given, I can determine that most of these, well, all of these angles will either be 120 or 60. So that is by a linear pair. Angle 3, so this guy right here, I can use two different things. So 1 and 3 are vertical, so I know those are corresponding, or I could do the same thing, that knowing that 2 is 60 degrees, 2 plus 120 is 180 degrees. But I like vertical angles better just because those are easier to see. Angle 4. Angle 4 is congruent to angle 2 because they're vertical angles, so 60 degrees. Vert, and we're going to say by angle 2. Angle 5, 120. If I just moved angle 1 down the line, that would be angle 5, so copied and pasted. That's going to be corresponding. Angle 6, 60, is corresponding to 2. Corresponding to 2. Getting two mouses again. So this little two lines right here means that you're basically saying it's the same thing as above. So just so you know, I didn't want to write corresponding again. I just was putting these double lines because it means copy down below. Angle 7, 120 degrees. And we could say that's alternate exterior. We could say that it's a linear pair. There's a lot of different ways that you can say that it's 120 degrees, but it's a linear pair to angle 6. And last one, angle 8 is 60 degrees. It is vertical to 6. Or it is alternate exterior, or it is a linear pair to angle 5. There are so many ways that you could know that angle 8 is 60 degrees. So like I said, once you find that one here, number 2, by doing 180 minus the angle that's given, you know that they're all going to be either 60 or 120 or whatever those two numbers that you found. The one that's given to you and then the one that you subtracted from 180. 3 gets a little bit more complex because we have to solve for x and then find the angle measure. So since I know these are alternate interior angles, I know these are congruent to each other. So I know that 3x plus 60 is equal to x plus 70. I could plug this into Desmos to figure out what x is. I can also do a little bit of solving. So if I wanted to get that full credit, I would get the x's on one side and the numbers on the other side. The easiest is just subtract x. So pull that line down, subtract x. 3x minus an x is going to be 2x plus 60 equals 70. Now I want the number to go on the other side, so subtract 60 from both sides. 2x is equal to 70 minus 60 is 10. 2 times x, divide x equals 5. Angle CBD. So angle CBD. That means that I'm plugging in x to find the actual angle. So 3 times 5 plus 60. 3 times 5 is 15. 15 plus 60 is 75 degrees. Since I already know that alternate angles are congruent, I know that angle BDF is also 75 degrees. I don't even have to solve or show my work because they are alternate interior. So again, if I was given maybe something like this angle, let's say like this was x plus 70, the only difference would be I would be adding the two equations to 180 degrees. So depending on what kind of angles they are, if they're congruent, set them equal to each other. If they are not congruent, like these two are definitely not congruent, set them equal to 180. So try a couple of these on your own, and then we'll go through the answers. So these are similar to this number 3. We're just solving for x or y, depending on what's given. So pause, see if you can do A, B, and C on your own. D, I'll go through. All right, we know that vertical angles are congruent to each other. So I know 3x equals 45. If I divide that by 3, x equals 15. Two x plus 16 and 3x minus 26, these are corresponding angles, which are congruent. So I can set 3x minus 26 equal to, let me start that over, 3x minus 26 equal to 2x plus 16. I can plug that into Desmos to get my x value. I can also solve, get the variables on one side, get the number on one side. I'm going to do it all in one swoop, just because. So 3x minus 2x is going to be x. Negative 26, positive 26 is going to cancel out. 2x minus 2x is going to cancel out to 0. 6 plus 26 is going to give us our final answer, which is x equals 32. C, we want to find x, and we're given two angles in this case. It doesn't really matter which one you use. We just, I think 128 or 52 is a lot easier to use, because I know that This guy right here is also 52 degrees because they're vertical angles. So then I know 7x plus 3 is equal to 52 degrees. Or just, yeah. Then I can solve, subtract 3, 7x equals 49, divide by 7, x equals 7. D is a little bit of a different angle relationship, but I know that all triangles, their angles add to 180. So if I know that 23 plus 58 plus whatever this value is, sorry, this guy, we're going to call it y, not x, is equal to 180. I can subtract 23 and 58 from 180. Get that this is 99 degrees. Now I know that these guys are a linear pair, so I know that 99 degrees plus x is equal to 180 degrees. My handwriting is getting worse and worse. So now I can find x by doing 180 minus 99, which is 81. More of these types of problems. F is definitely the hardest, so I'm going to go through F and then just set you up on E. So F. I know all of these three things add up to 180 degrees. This guy right here, this little box, means that this angle is 90 degrees. So that's helpful. We already know what y is. Now we know that all three of these angles add up to 180 degrees, which would be x minus 7 plus 3x minus 3 plus 90 equals 180. Solve for x, or plug this into Desmos and find what x is. X and 3x are going to be 4x. Negative 7 and negative 3 is negative 10 plus 90 is 80. Subtract 80 from both sides, you get 4x equals 100. Divide by 4, x equals 25. So then I could find whatever this angle measure is, 25 minus 7. 3 times 25 minus 3 would be this angle right here. All right, another puzzle. Another thing where if we find one angle, a lot of them are going to be the same angles. So I think starting off right now, I see that C is corresponding to 47. So I'm just going to say that this guy is 47 degrees. From there, the rest of them are not super easy. I guess A is pretty easy. A and 47 are vertical angles, so they are 47 degrees. B, I know all three of these angles add up to 180. So if I take 180 minus 92 minus 47. That's going to get me angle B, which is 180 minus 47 minus 92, 41. I then can also find D from that because they are on this line right here and they are alternate interiors. So that would also be angle of 41. And that's all we needed to find. Another way that you could have found D is, since you know C is 47 and this is 92 right here, they add up to 180 for a triangle. We could have subtracted. So big puzzle, thinking about all of your different angles, doing a little bit algebra to find if they're equal to 180. Triangle properties. So again, all triangles add up to 180. So 96 plus 21 plus x is 180. Or 180 minus 21 minus 96 is 63 degrees. This is a little bit tougher because we've got x's involved, but I know that they all add up to 180. So 3x minus 17 plus x plus 40 plus 2x minus 5 all equals 180. Plug that into Desmos to get your x value, or combine like terms and solve for x. I'm not going to go through that process because the hardest part is getting if it sets up to equal to 180 or if it is congruent to each other. If you got to this place right here, I believe you would get the majority of the credit that you need. And then if you plugged in from Desmos to get whatever x is, you should be good. All right. That was it for... Oh, that last one was actually... This one was from Unit 3, actually. So this last one, this number 1 that I just did is from Unit 3. I'll move on to another video for the rest of Unit 3.